like the College of Engineering because we have really good hands-on labs. The professors are really good.
At Colorado State, you get a special kind of atmosphere.
There's definitely a big relation here between what you're learning and what, how to apply it to real life.
There's definitely a lot of interactions between the faculty and the students. They know you by your first name. They know who you are. They know what you're doing, where you're going to go, what jobs you're looking at, internships.
I work for Solix Biofuels. We're at the Engines and Energy Conversion Lab, and they do a lot of different research here. And as an intern, I am currently working in their biology lab for Solix. Currently, they're taking algae and they're growing it using CO2, waste CO2, and they stress out those algae to make it produce lipids, and from those lipids, they can actually produce biodiesel. It's really interesting to actually be making a difference, like as far as the way our world works and stuff.
There are huge needs globally, and there are needs that we can meet through this combination of developing new technology and developing new innovative business models. And the really cool thing is that we can bring all these students along with us in this journey.
This is probably one of the best things that's on my resume right now.
We can also measure our transmit voltage, right?
The goal of our project was to work with people with disabilities and kind of allow them to be able to open doors without any sort of interaction whatsoever.
This project, we realistically started with nothing, and we've come to the point where we're allowing an individual to be able to go through a door with absolutely no interaction, with that door.
I know when we first gave the device to Terry and we first explained how it worked, and it worked for him the first time, and he approached the door and it opened, like he was really excited about it. He had a really big smile on.
Up to 0.7? This was our senior design project, and so we were electrospinning. And the whole purpose of electrospinning is to create fibers that are on the nanoscale length. You could use these nanofibers for biomedical type applications or biological type applications. I love the group projects. We do probably maybe 1 or 2 group projects a year, maybe 1 a class for engineering. And it's really important to be able to work with, work with a team and work with anyone. Our group, we're all focused in more of a biological aspect, and so it was really important for me personally to work on this because I want to go into more medical base. That's the #1 reason why I want to go into medical school, is to be able to make a difference and to help people out.
Yeah, I think you have to go back to ABC first.
This project was originated by a fellow out in Fort Morgan because he has muscular dystrophy, so he was wanting to be able to play video games even though he can't really move his hands much. And so our first goal was to find something that worked for him and then try to take that and expand it out to work for other people.
Well, it works.
That's excellent. It's definitely been a great experience to work on this project. I've learned a lot more than just what the classes will teach you.
Seeing him benefit from this project was really meaningful to me, just because I felt like we had made a difference in someone's life.
To be able to realize that you could really make a difference on a society is just, it's a good feeling.